In this video, we're going to use Google Cloud and BigQuery to practice SQL and porting data from a big relational database out of some cloud computing so that we can do some analysis in Python. So you're going to want to go to cloud.google.com in order to do this. And just a quick recap, what we're going to do is we're going to use our knowledge of SQL, where we're going to select from different databases where conditions are met. We're going to look at distinct values for different variables so we can tie together those databases. And we're going to look at creating joins. Inner joins are where the variable has the same people or the same entities within the two tables. The outer join is everyone in the two tables based on some common variable. And a left join, whatever table you list first is the left one. And so it'll be everyone for that variable in the left table versus a right join where it is everybody in the right table. So we're going to be using this SQL knowledge from our previous video to do some querying. So please go to google.cloud.com/free. And I'm just going to go there. So let's just walk through some steps and then we'll do it. So we're going to go to Google Cloud. Now, Google Cloud allows you to sign up for a subscription, pay them money, and that's because you can do way more than just query a public database, which is what we're going to do. You can actually store your company's or your organization's data there. You can do data visualizations. You can do machine learning built into Google Cloud. Now, we're not going to do all that because there's no expectation that you pay any money to Google in order to do this practice here. So we're going to use the free version. We're going to query a public data set, and then we're going to port it out into Python so that we can do our machine learning, our data analysis, our dashboards there without having to pay any money. So how do you do that? Well, first go to our website, go to the website here, cloud.google.com. Then we're going to click on the console on the top right. If you go through this route, you don't have to log in or provide a credit card. Then we're going to go to BigQuery, which is located by clicking on the lines on the left side of the word Google Cloud. And then we're going to go and we're looking for BigQuery Studio, and we're going to start with some New York street trees. So let's just do that. Let me get out of here. All right. So we're at cloud.google.com/free $HL equals EN because we want to be English. Choose a different language if that's your preferred language. On the right here, you see where it says console. Click there. Okay. Don't do this try it or a free tier log in. It's all going to ask for personal information and a credit card. Just go to console. Once you go to console, we want to go to BigQuery. And you'll have this main dashboard here. But on the far left, where it says Google Cloud, we want to go to the one that's called BigQuery Studio. So go to BigQuery Studio. All right, so now we need some data. And the easiest way to do this is if you can remember the name of one data set. It'll then show you all of them, which makes the life a lot easier. So where it says search for resources, we're going to type in New York, NYC. We're looking for NYC street trees. Okay, that's the one we're going to start with. But it doesn't really matter which one you start with as long as you know the name of one of them, because once you load it in, it gives you a list of all the public data sets. So here we're doing NYC street trees. Click View Dataset. And it's going to load it into your BigQuery Studio. Or crap out, whichever one. All right, so notice here on the left, this is the Explorer window. In this Explorer window, that's where you can access all of these public data sets. And so there's lots of them. New York trees is showing up on the bottom. You can click more because this has only gone through the letter G. There's more of them to find. We're going to look at some of these. But in order to access your New York trees, you're going to hit this little arrow that's next to it. And then you can actually click on the data set. So for example, if we do tree census 2015, what it shows you is it shows you the variables. See, we almost have a data dictionary here with field name, description, and we have the type of data that we have. So you can see that some of them are integer, some of them are string. My cat is on the table and he tends to actually turn off my computer. So I'll bat him away. All right. Someday you'll see him on screen because he is very persistent. All right. So we have the tree ID. And there are other pieces of information here. So this is information about each tree located in New York City. We don't need all of this data for our analysis, so we pick the ones that are most relevant to us. Now, in comparison, if we click on tree species, you can see this data set has information about particular species of trees. So the tree census was about the status of each tree in New York. This one here is about a species of tree in terms of how quickly they grow, what do they change color in the fall, how big do they get, what is their Latin name, what is their common name, and so on. So we want to merge these two together in order to create a data set for us to tie what's happening in New York City to information about the trees in New York City. Okay, so we have gone and we have found our New York street trees, and we can look at the different ones. This one says 1995. You'll notice that there's 3 sets of census for trees in New York that we could look at. There are lots of data sets in this big query. Some examples of some other ones. Well, you can look at San Francisco trees. We could look at text. And so in later videos, we're going to analyze text. And so there are sources of text. Hacker News and BBC News have article headlines and then text. And so we can analyze natural language processes. We can use this information to collect spatial data. So we can look at crime in Austin and Chicago. And by spatial, it has longitude and latitude. So we can pinpoint where things are happening. We can use Chicago taxi trips to look at the movement of taxis. We can pinpoint and track where they move on a graph. There are other machine learning data sets, so they're hidden under the label ML. And these are common data sets used to practice machine learning. One is a classification model about different characteristics of penguins. Another is a science data set called Iris that has different components of flowers. We can also look at credit card defaults, fraud detection. If you're looking for data sets as we move through some of these assignments and practice material, maybe you're into sports, there's ones related to baseball or NCAA. So lots of data sets that you can choose to pull and practice with as we do analysis, visualization, and machine learning models throughout our videos. So just to keep an eye on that, we may come back to some of those data sets and you might need to then export them as we're doing here so that you can do future analysis. So we'll come back to the trees, but let's take a look at 2 of those data sets, the Austin crime and the Chicago crime. So let's suppose that I would like to merge those together so I can figure out how many burglaries in 2015 are happening in Austin versus how many burglaries in 2015 are happening in Chicago, and do some comparison about the locations where these things are happening. In order to do this with MySQL, the first thing I would do is I would select distinct. So I would need to go in, and let's just actually pull it up here. So I'm going to go, let's go into Austin crime. So you'll find Austin crime towards the top because it's alphabetical. Austin crime, don't forget to toggle that little turn there so you can actually see the table. And so here we have the data that's in the Austin crime data. So we have a unique key identifier, we have primary type, and we have X and Y coordinates. We have some descriptions. We have the year. To get an idea about how this information is being portrayed, we first look at type. So we have strings, we have integers, we have the descriptions here. You can also look where it says preview, and it will show you what that data set looks like. So we can see here descriptions. There's all kinds of different descriptions. We're looking at primary type. Well, I can only see a little bit of these primary types here on this screen. So what I want to do instead is I want to do a query. So I'm going to click here where it says query, and I'm just going to do split tab so that we can put it all on the same screen. Okay, now notice it populates part of that for you. You have to specify the variable, but it's telling you already what database it's coming from. The other thing is that you see it says limit 1,000. That's because in the free version, where we're not paying Google or providing them our credit card number, we're limited to a sample size of 1,000. So let's say I want to look at, for this Austin data, the primary type. So notice when I click on primary type, when my cursor was here, this allows then it to populate. So it says select primary type from BigQuery public data.austin_crime.crime limit 100. Okay, so I want to select the primary type. Now what I want to do though is I want to actually select distinct, not just select, not just give me all of the primary type, but select distinct primary type from our Austin data. Notice that on the right, it'll tell you this query will run. So if there's something wrong with your code, it will tell you in red that there's something wrong. And then we can run it. So it puts on the bottom here, this list, I only asked for primary type, and I want the unique values. So robbery, burglary, auto theft, and so on. These are all the unique different ones. So there's probably repeats of these categories, but we get a list of the unique. So I'm thinking about tying this Austin data to the Chicago data. Well, let's go to the Chicago data, Chicago crime, and I'll toggle to get that table. I'm just going to make this go away so I can see it nicely here. So let's just take Chicago crime. I don't know why it's constantly wanting to put it over here. Put it here. I'm just going to make this go away. Clean it up for a second. Close, 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 close. Okay. Can you get me over here? Crime. There we go. Okay, so with the Chicago crime, I can see, again, unique key, and I have longitude and latitude, and I have also something called primary type. So what I want to do is a query to select primary type, and now we're doing it from the Chicago crime data. Again, it's limited to 1,000. I want to see select distinct because I want to see that list. So notice here I misspelled distinct. It says unrecognizable here on the right. So it'll tell you that there's something wrong and where there is something wrong. So we'll just change that. Come on. My poor little computer is about to kill itself. Too much happening here. D-I-S-T, distinct. There we go. No, what's unhappy about it now? Oh, random stuff at the end. Okay, so it's good. It says this query will run, and so we run it. And so here we get the list here. Now in both of those cases, I didn't tell it to order it, and so it is in random order. I would want to tell it to put it in order so that I could compare. So I'm actually just going to switch back to the slide here because we can see it a little bit better. So select distinct primary type from Chicago crime, order by primary type. That puts it in alphabetical order. That's the one that you see right here. Select distinct primary type from Austin crime, order by primary type, limit 1,000. That's the one you see here. Now, I have a problem. Notice that one is in capital letters, one is in lowercase. Notice that they use different terms. One has theft, colon, and then a bunch of different categories. The other one doesn't have that. So I actually can't merge these two tables because they don't have a common variable that overlaps. I can't merge the two tables at all. So if I want to do any type of analysis of these two tables, I essentially have to just analyze them separately, pull the databases separately. I can't use joins to combine them because they don't have anything in common. Now, if these two had something in common, so let's say when we're looking at the right at these two primary types, let's say they had the same formatting and the same words. So I wanted to merge them. Then I have a second problem. The second problem I have is that the variable primary type is the same name in both tables. Okay, so I could just specify the name of the table. So if we go back, one of the reasons that you would write your SQL like this as report_card.name and attendance.stud_name is because it's quite possible in your two tables, both variables are called name. In which case, this part before it, report_card and attendance, are the names of the tables. So this helps to distinguish what variable from which it is combining. Well, I have another problem with this data set. This data set, not only are both variables called primary type, but both tables are called crime. So notice here, if we were doing a join, let's suppose that these both said burglary, both lowercase, so we could match them together, okay? And they used homicide in both as opposed to homicide and murder, because those two can't be combined if they're two different. So if they had common language and formatting, then I could put on, and I'd want to put primary type equals primary type. But those are the same words, so it won't work. I could put crime.primary type equals crime.primary type, but it doesn't know whether it's Austin crime or Chicago crime. So I just want to show you an interesting feature you can use to help sort out which is table 1 and which is table 2. So notice here where I say select, and then I want to pull the unique key from table 1. I'm going to call it T1.uniqueKey. And when I pull the unique key from table 2, I'm going to call it T2.uniqueKey. So I'm going to give these labels to the two tables, even though they have a lot of the same name. And how does it know that you've given the label to which data set? It's in the from. From BigQuery public data.austin_crime.crime, we label it T1. And then BigQuery public data Chicago_crime.crime, we've labeled it T2, which means that up here in select, this comes from Austin, this comes from Chicago, T1, it's going to be in both. If you're doing an inner join, it doesn't really matter. Pick T1 or T2 because it's going to have to appear in both. If you're doing a left join or a right join, then you can specify here the primary type, if it's a left join, is coming from Austin. So it's a T1. If it is a right join, it's coming from Chicago, and then it's a T2. And then where are you pulling the year from? So select, and I'm putting T1 and T2 to help indicate I'm pulling which variable when they have the same names from which data set. And then here, where they're both named primary type, I am telling it that T1, table 1, the Austin table primary type, is equal to the table 2, the Chicago primary type. In this particular example, one of the data sets has 2014, 15, 16, and the other one has lots more years than that. So if I want to control for the year, so I'm doing an inner join, I want the types of crime that appear in both. I want it to be consistent in terms of years, so I can compare how much burglaries there were in Austin versus Chicago in 2015. And so this where here restricts particularly the Chicago data to between 2013 and 2017, so I have the same years as the other. Now, I can't run this query for you. It won't work because, again, if the primary keys here are not, or sorry, the four, you don't have a foreign key. These two variables don't match. They have to match at least a little bit to do any type of join. Okay. All right, so that's not going to work. So let's try something that will work. How about we create a data set that contains information from the New York tree species data set and the New York tree census from 2015, that data set we started with. So let's suppose we want to create a data set that has a particular tree in New York, the zip code where it's located, the borough, Queens, Manhattan, the Bronx, its status, and its health. So specific to the tree, that's going to come from the census. Then we want information once we know what kind of tree it is. We want the scientific name of the tree, the common name of the tree, how much it grows, does it have fall colors, how big it gets. And now we've created this data set that's not just the health of each tree in New York and not just information about tree species, but now we know information and details about each tree in New York in terms of fall colors, growth rate, and so on. All right, so go back into BigQuery. We want to go into our New York trees. I'm just going to close a bunch of this stuff. And so pause the video, take a moment, and see if you can create this query. What type of join is it? What does the query look like? So we want to go to New York trees. We have our tree species. And our tree census. So take a moment and see if you can build the SQL code. So first thing I want to do is we want to see if we can even merge these together. So we want to, in our split tab here, we want to select distinct. So let's start with tree species because that's the one I happen to have open. And what we are looking for example, is can we use the scientific name to merge the two? So again, select distinct, species, scientific name. This query will run. We run this. And we see the list here. Okay. And we can also put in order. And we can order by that same scientific name. Okay, and of course I need a space there for it to be happy. All right. Order by. All right, this query will run. So I run it. Now it's in alphabetical order. So we can start with the ACER, and then what we're going to do is repeat the process, but with the census data. And so with the census data, I can see that there is something called species Latin. So if I choose scientific name, that's probably similar to the Latin name, whereas common name is probably common. So you can pick either one to match them. And so here we're going to go species Latin. So let's do a query. And in this case, let's do species Latin. Let's do distinct from, and then in order to make sure that we have some same names, let's put it in an alphabetical order. So order by, and then you can click on species Latin or you can type it to get it to populate right there. And then this query will run. So let's hit run. And so we can see some ACERs, and we can see here some ACERs. So we can start to look for, are there some similar names? So Acer rubrum, Acer rubrum. Don't know how to pronounce any of this stuff. Don't know anything about trees. Background is business, not science. But we can see though, as we scroll through, that they have similar formatting and similar names, which means we can do a join. So then the question becomes, what kind of join do we want to do? What is appropriate for the information that we want? Well, we wanted to take and combine the data sets so that we had everything that had a tree in New York. We want to know the species information about it. So you could do a left join, in which case you have all the information about the New York trees, and then you pull in any relevant species information, growth rate, fall color, tree size that exists. You're going to have some empty spaces if there's trees in New York that aren't appearing in our species data set. So probably what we want is we want the full information. If you want only that data set that has completed all the variables from the two data sets combined, you want an inner join. Okay, we definitely don't want a right join, because what's the use of having species information if there's no New York tree equivalent? And a full outer join is everything combined, and we really just want to get at the combined information. So let's create an inner join. So how do we do that? Well, we say, okay, what is the data we want? So we're going to select the data we want, tree ID, zip code, borough name. Notice that some of these are coming from one data set and some of them are coming from the other. We then specify where. So let's do our New York tree species. That's going to be the left table. It doesn't matter if you're doing an inner join. It doesn't matter which order you put these tables in. Simply that when you do your on, we're going to need to represent how the two are tied together. So we have our New York tree species inner join with our tree census 2015 on, and we could do tree underscore species, and we'd have to go back and check which one had the Latin. So it was the tree census that had the Latin, and it was the tree species that had the scientific name. So we could have this say tree species scientific name, and we could have this say tree census 2015 Latin. Because these are unique variables that don't appear in each other, you don't actually have to tell it which table it's from. If there are variables that have the same names, then what you can do, remember, is go make this T1, make this T2, and then you can do T1 dot, T2 dot, and then same thing here, you would specify that which one it came with by putting our label. This is T2, this one here is T1, and you would label all of them. So if you have variables that have same names in tables, then you want to do this labeling system. I'm just going to undo that there because I will totally forget. All right, so let's do this in SQL. And you don't have to have all this open. This is a lot going on at once, so I'm just going to close everything up. Okay, and I will do a new query, and I will just do it in split tab. You can do it as a new tab because you no longer need to see all these pieces. But we're going to, and you can see because I have the tree species table open, it's starting with the tree species. So you could start here and then type in that I want species scientific name, comma, what else do we want? We want species common name. I want growth rate. I want fall color. I want tree size. Okay. You can also add them simply by clicking here. It'll auto add them to your thing. So if, for example, I erase this and then I click on these, it'll add them. Just make sure you have your, just check them to make sure that you have every spacing and commas correctly. So you can do it that way as well. We would need then to pull up the other database. So that was the tree species. We need to pull up the 15 because we're including both. And so I'm just going to take this one here. just for the sake of time. Okay, so I'm gonna take, I got tree ID, got zip code, got borough name, status, health, and species scientific name, common name. So you can see all of these are coming from the table, the tree species table. Fall color. Okay, we got our tree size. Okay. All right, so we're selecting all of those. Why doesn't it like tree ID? Okay. And then we need to tell it where we're selecting it from. That's the next stage. And so we can see here we were selecting from these two data sets, and we have our inner join. And you can also, to make it easier, I just put it as each row. Okay, so we are doing an inner join, and then it's complaining because if you do an inner join, you have to tell it what you're joining on. So remember, no matter what kind of join you have to specify what variables tie together. So we're going to tie here. You can put it on the same row, you can put it on different. All right, and all right, we don't pay money for this, so limit 1,000. All right, it says this query will run. We hit run. And what you get here is a table of information. So here we have the borough of Manhattan. Here we have their status, alive or dead, whether they're healthy, and then scientific name, common name, growth rate, fall color, tree size, all of that's combined. So now that we have information on all of this, we can then export it to Python to do some analysis. And so in our next video, we'll look at how to export our data.